All right, starting over again. This is a section on doing area takeoffs. The reason why we do these is it's in preparation for doing load calcs. So we need to describe our building with the area of the floor, area of the roof, the area of the walls, and that's all that's required in this part of the load calc is the area of all those ideas. We have a command called RDD, which is a Pittman special command. Um, to use it, just type in RDD and you start picking the edges of your walls that we're here to measure. Um, this is to measure the square footage of the space. So not the actual walls themselves, but the area contained. I am type C to complete the thing. And you pick, oh, look at that. The text came in really, really small. Well, that's annoying. How big is this text? Oh, it's tiny. So we're going to do this again. This time we're going to remember to do what I should have remembered, which is set your scale. For legibility, it doesn't matter what the scale is in this case. So we're going to use 1/8 inch because it's nice big letters that you can read from far away. So RDD again, and that will now pick up the size of the text a little better. Didn't pick it that time. And you see I'm kind of making an imaginary boundary there. That's
Hmm.
because we're uh, making an imaginary boundary. Yes, it goes through and the air will move through here. But this is the tenant's space. So we're making an imaginary boundary because that's what they're responsible for. So 2,300 square feet for that one space. Rinse and repeat. We will do the rest of these real quick. Maybe. Now, if it looks a little sloppy, that's okay. The crooked lines don't bother me. If they bother you, then make them straight. But in the overall scheme of things, we're talking about quarters of an inch of a square foot. It's not really important as long as we get 227. Notice there's no decimal point. That's because I
Hmm.
intentionally made it round up. So continuing on, we'll do the back of the house here. And so forth. Now, these are all about the same size. If they were closer in size, if they were not very close in size, I'd measure each one of them individually. But since they are within a few inches difference, I'm going to take the whole entire thing. So I'm going to do an RDD, and I'm going to encompass all of the restrooms here because we can divide by 4 when we go to do our calculations.
Hmm.
This saves a lot of computing power because each one of these needs to be individually count and it takes extra time. So we will group them together, save that computing power. It's also important to note that some of these, you won't know it yet, are different occupancy types. So this is a retail occupancy. These are restroom occupancy, and so is this over here. This is a freezer. Do we model that? The answer is no, because that is conditioned by the freezer guys, and we don't have anything to do with that. So I'm very happy with that.
Mm.
Um, let's leave it there for now. We can do the rest of this. I just don't waste the time. Now, the next part of doing area takeoff, we now have the roof square footage. We also have the floor. 2 for 1 bonus for us. Now we need to use our special measurement tool here. It's called the glazing tool. It does anything you want horizontally or vertically. So we'll use this. If you notice down here, it says enter the window or wall height in feet. Okay, I happen to know that this building was 12 feet on the walls. You need to check your plans or ask your architect if you don't have plans, or ask the engineer you're working for if he knows. You can't just assume a height. So I'm going to say it is 10 feet. I'm sorry, I said 12 feet. 12 feet. And now it's saying pick an area to measure. So we're going to pick this one contiguous wall. So it's from here to here. There's no breaks in the wall, it doesn't change direction, and there's no other zones in there. So there, it measured it. It's 1,100 square feet. It's very happy. Now, there is a little break in this wall, but how much of the wall is facing south? Because when we go to enter the data, that much is
south.
that's all facing south. How much is facing east? Well, a little bit. So we will measure that. And if you can use your imagination, it's going to be the same on this side.
Yeah.
So you don't have to measure both of them. Now, delete this. Okay, that is all the walls. Now, this building has some windows. We didn't measure windows, did we? So the windows are a different height. Also, one of those things you need to either from field measurements or from plans, you need to find out what the height is. So we're going to start a command again, glazing tool, and C will change it. Change the height. This one's 8 foot and it's in feet. If it's a decimal foot, then you'll have to do that math. If it's 8'6", it's 8.5. All right, so we know how high it is, or now we're going to measure how wide it is, and it's going to do the math for you. I put the window dimensions on the inside of the building and the wall ones on the out. And that's just my methodology. However you would like to keep them separated, it doesn't matter to me. But now you know how many square feet of glazing for this one space is. Looks like there's some glazing here. This may be a different height. This looks like it might be a side entrance, so it's probably the same height. So I'm going to assume it is the same height in this case. As windows are a really big portion of the heat gain, you need to be very sure about those windows. This might have been just a drive-up window. And look, I put the dimensions in the wrong spot. Bad engineering, I've done it. This might have been a drive-up window. Well, how big is a drive-up window? They're only like 3-4 feet, maybe. So let's say 3.5 feet. We should know, but I don't know in this case. So start the glazing tool again. Wherever it goes, there it is. And type in C, and we're going to say 3.5 feet. And we measure it.